Section 2.2, Biconditionals and Definitions. A biconditional occurs when a conditional and its converse are true. The statements can be combined into a biconditional statement. Here, we have our original conditional. We know that is the hypothesis and conclusion represented by P and Q, and is stated if P then Q. The converse is when we switch the hypothesis and conclusion, and we create if Q then P. And a biconditional, if these two statements are true, then I can write a biconditional in the form of P. Now, if you can see, the symbol is a double arrow, which means it can go in either direction. And it is written as P if and only if Q. On this example, they want us to determine if the conditional is true. If so, write the converse, then determine if the converse is true. If both are true, write as a biconditional. Here's our conditional. If segments are congruent, then they have the same measure. The first thing that we should always do when having a conditional is identify our hypothesis and conclusion, our P and Q. Our hypothesis is segments are congruent, P, and our conclusion, they are the same measure, is Q. This is true. Remember, for segments to be congruent, they must be the same measure, so that is true. Now what we have to do is create the converse. Here our converse is just switching P and Q. If segments have the same measure, then they are congruent. Again, that is true. So now we have a true conditional, a true converse. And when that occurs, we know that we can write a biconditional. And our biconditional is segments are congruent if and only if they have the same measure. In this example, we have the same directions as our previous slide. So we're given a conditional. If the ray is an angle bisector, then it divides the angle into two congruent angles. Let's identify our hypothesis. The ray is an angle bisector, is P, and it divides an angle into two congruent angles, is Q. That is a true definition. If it is an angle bisector, it divides the angle into two congruent angles. This is true. We can now identify and create the converse just by switching P and Q. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. This is also a true definition. Since this occurred, we can now write a biconditional. In other words, P if and only if Q. And when we do that, a ray is an angle bisector if and only if the ray divides an angle into congruent angles. Again, when we write biconditionals, converses, or conditionals itself, we may have to add words or deduct words to make the sentence make sense for all readers. On this example, write the two statements that form each biconditional. Here I'm given a biconditional. A person lives in the Windy City if and only if the person lives in Chicago. I have to identify the P and the Q to make this work. A person lives in the Windy City is P. That's my hypothesis. My conclusion is the person lives in Chicago is Q. So I have to write the original conditional off that. If P, then Q. If a person lives in the Windy City, then the person lives in Chicago. Here I have my P, and then I have the Q. Next, I'll write the other conditional off of that, or converse of that, and if a person lives in Chicago, then the person lives in the Windy City. Again, we want to write two statements that form each biconditional. We know when I have a biconditional, the original conditional is true and its converse is true. Let's identify the P and the Q. Lines are skew. That would be our P, our hypothesis. If and only if the lines do not intersect and are not coplanar, the lines do not intersect or are coplanar, is my Q. Now I have to form two statements from that. And my first statement, if lines are skew, then they do not intersect and are not coplanar. And all I have to do is switch my P and Q from my first conditional that I wrote, And when I do, I get if lines do not intersect and are not coplanar, then the lines are askew. And of course, we know from the definition of biconditional, both of these conditionals must be true. On this example, they want us to test each statement to see if it is reversible. If so, write it as a true biconditional. If not, write not reversible. Reversible means that if I have a conditional, if P then Q, and that is true, then I continue to the converse, if Q then P. And if that is true, that means that the two statements are reversible. If they're reversible, I can write it as a biconditional. Here I have my statement. Parallel lines are coplanar lines that do not intersect. I have to write that as two conditionals. Therefore, what I need to do is to identify the hypothesis. Here, parallel lines is my hypothesis, or P, and my Q are coplanar lines that do not intersect. That is my Q. And I've written the first conditional. If lines are parallel, then they are coplanar and do not intersect. That is a true statement. Since it's true, I will proceed to the converse. If it wasn't true, then I would know that they're not reversible, and I could just write not reversible. But since it's true, I can then write the converse, then test that. If lines are coplanar and don't intersect, then they are parallel. That is also true. Since these are both true, I know that they're reversible. Therefore, I can write if P then Q, or if Q then P, and they're both true. Since that occurs, I can then write a biconditional. Lines are parallel if and only if they are coplanar and do not intersect. Also, to be able to write conditionals, converses, and biconditionals, to know that they're true, I must know the definitions of geometry in prior sections. Again, on this slide, they want me to test each statement to see if it's reversible. If so, write it as a true biconditional. If not, write not reversible. Here's my statement. I have two angles form a right angle are complementary. Two angles that form a right angle are complementary. So two angles that form a right angle, that's P, are complementary is Q. So if I have two angles that add up to 90 degrees and they form a right angle, then they are complementary. That's the definition of complementary angles. The sum of two angles is 90 degrees. In this case, they happen to form a right angle. They're adjacent. That's true. Now what I have to do is to write two conditionals and determine whether they're true. If they're true, they're reversible. Then I can write a biconditional. Here's my first statement. If two angles form a right angle, then they are complementary. We've already talked about that. That is a good, solid definition for that. I have two angles that form a right angle. Therefore, the two angles add up to 90 degrees, and that is the definition of complementary. So this is true. My next statement, I'm going to write the converse of my original conditional here. If two angles are complementary, then they form a right angle. This is false. Just because they're complementary doesn't mean they form a right angle. I could have two angles that are not adjacent. For example, 30 degrees, and I have another angle over here that is 60 degrees. These two angles are complementary, but they don't form a right angle because they're not adjacent. Therefore, this is false. And my conclusion is that these are not reversible. On our next slide, we want to know what a good definition is. A good definition helps you clarify, identify, and classify terms. There's three parts to a good definition. Number one, they must use clearly understood terms, terms that we all understand and have a common point to start from. Number two, a good definition is exact. It does not use almost, close, big, small. We have to be in exact terms so we all know what we're all talking about. And number three, it must be reversible. Therefore, if P then Q is true, I have to have if Q then P is also true. And we know that would be a biconditional. Let's look at some examples. Is each statement below a good definition? If no, let's explain why. Number one, a fish is an animal that lives in water. Here, this is not a good definition. A whale and a dolphin are classified as mammals. They live in the water but are not fish. Therefore, this is not a good definition. Number two, Perpendicular lines are lines that intersect to form right angles. This is a good definition. We have two lines that intersect and they form right angles. That is the definition, and it's clearly understood what's happening. That's a good definition.